Welcome to the chapter on Physics Basics for Civil Engineers. Understanding physics is crucial for solving real-world civil engineering problems. In this chapter, we will cover the basics of mechanics, statics, and dynamics. These principles are essential for understanding and solving engineering problems. Mechanics is the branch of physics that deals with the motion of objects and the forces that affect that motion. It is divided into two main areas: kinematics and dynamics. Kinematics is the study of motion without considering the forces that cause it. It involves parameters such as displacement, velocity, and acceleration. Displacement, denoted as vec d, is the change in position of an object. Velocity, denoted as vec v, is the rate of change of displacement with respect to time. Acceleration, denoted as vec a, is the rate of change of velocity with respect to time. Let's go over the three equations of motion that apply when there's constant acceleration. First, we have vector v equals vector u plus acceleration times time. In this equation, vector v is the final velocity, vector u is the initial velocity, a represents acceleration, and t stands for time. This equation shows how velocity changes over time when an object is accelerating. Next, we have vector d equals vector u times time plus 1/2 of acceleration times time squared. In this equation, vector d is the displacement, which tells us how far the object has moved. This helps us calculate the distance traveled when we know the time, initial velocity, and acceleration. Finally, the third equation is vector v squared equals vector u squared plus 2 times acceleration times vector d. This equation connects the object's velocities and displacement, showing how they are related through acceleration. Together, these three equations provide a clear understanding of an object's motion when it's under constant acceleration. Dynamics is the study of the forces and torques that cause motion. It is based on Newton's three laws of motion. Newton's first law, also known as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Let's break down Newton's second law of motion, also called the law of acceleration. It states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The equation that represents this is vector F equals mass times vector A. In this equation, vector F is the net force applied to the object. The mass of the object is represented by m, and vector A is the acceleration that results from the force. This means the greater the force acting on an object, the greater its acceleration. But if the object has more mass, it will accelerate less for the same amount of force. Newton's third law, also known as the law of action and reaction, states that for every action, there is an equal and opposite reaction. Statics is the branch of mechanics that deals with bodies at rest or in equilibrium. In statics, the sum of all forces and the sum of all moments, or torques, acting on a body must be zero. For a body to be in equilibrium, the following conditions must be satisfied. First, the sum of all horizontal forces must be zero, denoted as sum Fx equals 0. Second, the sum of all vertical forces must be zero, denoted as sum Fy equals 0. Third, the sum of all moments about any point must be zero, denoted as sum m equals 0. When designing a bridge, civil engineers must ensure that the structure is in equilibrium. They calculate the forces acting on the bridge, including the weight of the bridge itself, the weight of vehicles, and environmental forces such as wind and earthquakes. By applying the principles of statics, they ensure that the bridge can support these forces without collapsing. In civil engineering, dynamics is crucial for understanding how structures respond to time-varying loads, such as those caused by earthquakes, wind, and moving vehicles. During an earthquake, buildings experience dynamic forces that cause them to shake. Civil engineers use the principles of dynamics to design buildings that can withstand these forces. They analyze the building's response to seismic waves and ensure that it remains stable and safe during an earthquake. Understanding the basics of mechanics, statics, and dynamics is essential for civil engineering students. These principles form the foundation for analyzing and designing structures that can withstand various forces and motions. By mastering these concepts, students will be well equipped to tackle real world engineering challenges.